Imagine a world where every ocean is frozen solid, where continents are buried under miles of ice, and where even the equator is locked in a permanent winter. This is not science fiction. This is one of the most extreme and mysterious events in Earth's history, known as Snowball Earth. Hundreds of millions of years ago, our planet may have transformed into a frozen sphere, a world where life was pushed to the very edge of extinction. But how does an entire planet freeze? How does Earth, a world full of oceans and life, turn into a giant snowball drifting through space? To understand this, we have to go back in time, long before dinosaurs, long before mammals, to a world that looked nothing like today. Around 700 million years ago, Earth was already a living planet. But life was simple. Tiny organisms filled the oceans, slowly shaping the atmosphere. At this time, the continents were arranged differently, clustered near the equator, where sunlight was strongest and temperatures were relatively warm. But something began to change, slowly at first, almost unnoticeable, but powerful enough to alter the fate of the entire planet. The key to this transformation lies in a simple but dangerous process called the ice-albedo effect, a feedback loop that can turn cooling into catastrophe. When ice forms, it reflects sunlight back into space instead of absorbing it. This means less heat stays on Earth, causing temperatures to drop even further. As temperatures drop, more ice forms. And as more ice forms, even more sunlight is reflected away, creating a cycle that feeds itself endlessly. It is a chain reaction, a runaway effect, where cooling leads to more cooling, pushing the planet toward a frozen state. At some point, this process crossed a critical threshold. Ice began spreading from the poles toward the equator, covering more and more of the planet. Oceans that once absorbed sunlight and supported life started to freeze over, cutting off heat exchange between the ocean and the atmosphere. Cloud patterns changed, winds shifted, weather systems collapsed into something entirely different from what we know today. The Earth was losing its ability to regulate temperature. The balance that kept the planet stable was breaking apart. And then it happened. The tipping point. Ice reached the equator. The last warm regions of the planet were swallowed by an expanding shell of ice. The oceans froze, not just at the surface but deep below, forming thick layers that could stretch for kilometers. The continents were buried under glaciers, crushing landscapes beneath their weight and reshaping the surface of the Earth. The planet had become a snowball. From space, Earth would have appeared as a white frozen sphere, reflecting sunlight like a mirror, with almost no dark surface to absorb heat. Temperatures may have dropped to levels far below anything experienced in modern times, creating a world hostile to almost all forms of life. For life on Earth, this was not just a challenge, it was a crisis of survival. Most organisms could not survive such extreme conditions. The oceans, once full of life, were now sealed beneath thick ice, cutting off sunlight. Photosynthesis, the process that many organisms relied on, nearly stopped. Without sunlight, food chains began to collapse. But life did not disappear completely. Somehow, against all odds, it survived. Scientists believe that small pockets of liquid water may have existed beneath the ice or near volcanic regions, where heat from the Earth's interior kept water from freezing. These refuges became the last safe havens for life, where microorganisms clung to existence in one of the harshest environments imaginable. It is here, in these hidden pockets, that life endured, waiting for the frozen world above to change once again. But if the Earth froze so completely, how did it ever recover? What could possibly melt a planet-sized ice cube? The answer lies deep within the Earth itself. Even during a global freeze, volcanic activity did not stop. Beneath the surface, volcanoes continued to erupt, releasing gases into the atmosphere. One of these gases was carbon dioxide, a powerful greenhouse gas capable of trapping heat. Normally, carbon dioxide is removed from the atmosphere through weathering processes, but with the planet covered in ice, these processes slowed dramatically. This meant that carbon dioxide began to build up in the atmosphere over time, creating a growing blanket of heat-trapping gas. For millions of years, this buildup continued, slowly increasing the planet's ability to retain heat. At first, the effect was small. The ice remained. The world stayed frozen. But eventually, the concentration of carbon dioxide reached a critical level. The greenhouse effect intensified, trapping more and more heat, and then, just as the freezing had reached a tipping point, so did the warming. The ice began to melt. At first, it was gradual. Small patches of water appeared. Dark surfaces were exposed, absorbing sunlight and accelerating the warming process. Just as the ice-albedo effect had driven the freezing, it now worked in reverse, amplifying the melting. More melting led to more heat absorption, which led to even more melting. The frozen Earth began to thaw rapidly. Oceans that had been locked under ice for millions of years returned to liquid form, releasing trapped gases and reshaping the atmosphere once again. Massive floods may have occurred as glaciers melted, carving landscapes and altering the surface of the planet. The transition from a frozen world to a warm one was likely dramatic, chaotic, and transformative, and with the return of liquid water and sunlight, life began to recover. But something had changed. The harsh conditions of Snowball Earth may have acted as a filter, eliminating weaker life forms and allowing more resilient ones to evolve. Some scientists believe that this extreme event played a role in triggering the rise of more complex life on Earth. After the ice melted, the planet entered a new phase, one that would eventually lead to the explosion of life known as the Cambrian explosion. In this way, Snowball Earth may not have just been a disaster. It may have been a turning point, a moment in history that reshaped the future of life on this planet. But even today, the idea of Snowball Earth is still debated. Some scientists argue that the planet may not have been completely frozen, suggesting instead a slush-ball Earth scenario, where some open water remained. Others point to geological evidence, such as glacial deposits found in regions that were once near the equator, as proof of extreme global freezing. The truth is that we are still uncovering the details of this ancient mystery. What we do know is that Earth has the ability to change dramatically, far beyond what we experience in our daily lives. The story of Snowball Earth is a reminder of how powerful natural forces can be and how fragile the balance of our planet truly is. It shows us that even a world full of life can be pushed to the brink of extinction, and yet it also shows us something else, that life is incredibly resilient, that even in the most extreme conditions, life finds a way to survive. Today, as we face our own environmental challenges, the story of Snowball Earth carries an important message. It reminds us that Earth's climate can change in ways that are both sudden and extreme. It reminds us that the systems that keep our planet stable are delicate, and that small changes can lead to massive consequences. But it also reminds us of the strength of life and its ability to adapt, evolve, and continue. The frozen Earth of the past may seem distant and unreal, but its lessons are more relevant than ever, because the forces that shaped Snowball Earth still exist today, and the future of our planet will depend on how we understand and respond to them. So the next time you look at the world around you, remember this. There was a time when all of this was ice, a time when the oceans were frozen, the continents were buried, and life was on the edge of extinction. A time when Earth itself became a snowball drifting through space. And yet, from that frozen silence, life returned, stronger, more complex, ready to begin a new chapter. There was a time in Earth's distant past when the planet, the blue world filled with oceans, forests, and life, almost disappeared beneath a layer of ice. Not just at the poles, not just in the mountains, but everywhere, from pole to pole, from continent to continent. Even the equator, the warmest part of the planet, may have been buried under ice. This is the story of Snowball Earth, one of the most extreme climate events in Earth's history, when our planet may have transformed into a frozen sphere drifting silently through space. But how could something like this happen? How does an entire planet freeze? And more importantly, but how does it survive? To understand Snowball Earth, we have to travel back more than 700 million years, long before dinosaurs, long before plants covered the land, and long before humans ever existed. At this time, Earth was a very different place. The continents were not where they are today. Instead, they were clustered together in large land masses, many of them positioned near the equator. This might sound like it would make the planet warmer, and for a time it did. Warm, shallow seas surrounded these land masses, filled with microscopic life. These tiny organisms, especially photosynthetic microbes, were slowly transforming the atmosphere by producing oxygen. This process had already begun hundreds of millions of years earlier during the Great Oxidation event, changing the chemistry of the planet forever. But Earth's climate system is delicate. Small changes can trigger massive consequences, and that is exactly what happened. The exact trigger of Snowball Earth is still debated, but scientists believe several factors may have worked together. One key factor was the movement of continents. As land masses drifted toward the equator, they increased a process called chemical weathering. When rainwater reacts with rocks, it pulls carbon dioxide out of the atmosphere. Carbon dioxide is a greenhouse gas. It traps heat. So when more carbon dioxide is removed, the planet begins to cool. At first, this cooling is gradual, but over time it builds, and eventually it reaches a tipping point. Ice begins to form at the poles. This is where a powerful feedback loop begins, a process known as the ice-albedo effect. Ice reflects sunlight. Unlike oceans or land which absorb heat, ice sends sunlight back into space. So as ice spreads, less heat is absorbed by the planet. This causes temperatures to drop further, and as temperatures drop, more ice forms, which reflects even more sunlight, which causes even more cooling. This is not a slow process anymore, it is a chain reaction. Once this feedback loop begins, it becomes incredibly difficult to stop. Ice spreads from the poles toward the equator. Oceans begin to freeze, weather systems change, cloud formation shifts, winds behave differently. The entire climate system starts to collapse into a new state. Eventually, ice reaches regions that were once warm year-round. Tropical seas begin to freeze. And then, something extraordinary happens. The equator freezes. This is the moment when Earth crosses the threshold into a snowball state. At this point, almost the entire surface of the planet is covered in ice. Oceans are sealed beneath thick layers that may be hundreds of meters or even kilometers deep. The continents are buried under massive glaciers that grind slowly across the land, reshaping everything in their path. From space, Earth would no longer appear blue. It would shine white, reflecting sunlight like a giant mirror. The transformation into a snowball Earth would have been catastrophic for life. Most life at this time existed in the oceans, but with the oceans frozen over, sunlight could no longer penetrate the surface. Photosynthesis, the process that produces energy for many organisms, would nearly stop. Food chains would collapse, ecosystems would break down, temperatures would plummet to extreme levels, possibly reaching far below anything seen in modern times. For many organisms, survival would be impossible, but not for all. Despite the extreme conditions, life did not disappear. Some organisms found refuge in isolated environments. Beneath the ice, near volcanic vents on the ocean floor, heat from the Earth's interior created pockets of liquid water. These hydrothermal vents provided both warmth and chemical energy, allowing life to continue in darkness. Other possible refuges included thin regions of ice near the equator, where sunlight might still penetrate enough to support limited photosynthesis. These small, isolated pockets became the last strongholds of life on Earth. It is here, in these hidden refuges, that life endured the longest winter in planetary history. Snowball Earth was not a short event. It may have lasted millions of years. During this time, the planet remained locked in ice with very little change at the surface. But beneath the surface, something important was happening. Volcanoes continued to erupt. Even though the surface was frozen, Earth's interior remained active. Magma pushed upward, and volcanic gases were released into the atmosphere. One of these gases was carbon dioxide. Under normal conditions, carbon dioxide is removed from the atmosphere through weathering. But with the planet covered in ice, weathering nearly stopped, so carbon dioxide began to accumulate. Year after year, century after century, million after million years. The atmosphere slowly filled with greenhouse gases, trapping more and more heat. Eventually, the buildup of carbon dioxide reached a critical level. The greenhouse effect intensified. Heat that would normally escape into space was now being trapped. At first, the change was subtle, but then it accelerated. Temperatures began to rise. Ice started to melt. At first, only small patches. But these patches exposed darker surfaces beneath, ocean water and land. These darker surfaces absorbed sunlight instead of reflecting it. This reversed the ice-albedo effect. Now, instead of cooling, the feedback loop caused warming. More melting led to more heat absorption, which led to even more melting. The frozen Earth began to thaw. The end of Snowball Earth was likely dramatic and chaotic. As ice melted, vast amounts of water were released. Glaciers collapsed. Massive floods reshaped the land. Oceans, once sealed beneath ice, returned to liquid form. The atmosphere, filled with carbon dioxide, created intense greenhouse conditions. Temperatures may have risen rapidly, transforming the planet from a frozen wasteland into a hot, humid world. This sudden transition would have had massive effects on chemistry, weather, and ecosystems. After the ice melted, Earth entered a completely new phase. The oceans were rich in nutrients, released from rocks during the glaciation. The atmosphere had changed, the environment had reset, and life, which had survived in isolated refuges, now had new opportunities. Not long after these events, something incredible happened: the Cambrian explosion. Life began to diversify rapidly, producing complex organisms with new forms and structures. Some scientists believe that the extreme conditions of Snowball Earth played a role in triggering this explosion of life. By pushing life to its limits, it may have driven evolution in powerful ways. How do we know any of this happened? The evidence comes from rocks. Geologists have found glacial deposits in regions that were once near the equator. These rocks show signs of ice movement in places that should have been warm. There are also unusual layers of sediment known as cap carbonates, which formed rapidly after glaciation, indicating a sudden shift from cold to warm conditions. Together, these clues tell the story of a planet that froze and then thawed. Not all scientists agree that Earth was completely frozen. Some propose a slushball Earth model where parts of the ocean remained ice-free. This would make survival easier for life and reduce the severity of the event. The truth may lie somewhere in between, but regardless of the exact details, there is no doubt that Earth experienced one of the most extreme climate events in its history. Snowball Earth is not just a story about the past. It is a reminder of how powerful climate systems can be. It shows how small changes can lead to massive transformations, and it highlights the delicate balance that keeps our planet stable. Today, we are once again facing global climate changes. While the causes are different, the lesson is the same. Earth systems are interconnected, and when they shift, the consequences can be enormous. There was a time when Earth became a frozen world, when life nearly disappeared and when survival seemed impossible. And yet, life endured, it adapted, it survived, and it came back stronger. The story of Snowball Earth is not just about ice. It is about resilience, it is about transformation, and it is about the incredible journey of life on this planet.